Section 4.3 is titled Writing Functions. So to write a function rule, the first thing you need to do is make sure that you're looking for a relation, essentially what's happening between x and y. And we write it in the form of a pattern, or we write it in the form of an equation using that pattern or that relation. So for example, we'll have y equals x plus the pattern. It could be subtracting the pattern, it could be multiplication by the pattern, but some relationship between x and y. So we'll start with some simple task, just looking at a chart and trying to write the function rule. So remember that the x is your input. So when we put in the numbers 1, 2, 3, and 4, our outputs are -1, 0, 1, and 2. So what you need to ask yourself is what happens from x to y, and then you need to make sure that that pattern is consistent throughout the table. So a couple of things you might think about. First, to get from 1 to -1, you could think, well, you multiply by -1. 1 times -1 does give you -1. The other thing you might notice is if you start with 1 and you subtract 2, you also get to -1. So the question is, what happens throughout the rest of the table? Well, if I take -2 and I multiply it by -1, I do not get 0. So that automatically rules out that relation. But if I take 2 and I subtract 2, I do get 0. Also, 3 minus 2 is 1, and 4 minus 2 is 2. So you can see that we are subtracting 2 as our function rule. So that means to get any output, you're going to take the input and subtract 2. So the function rule is y equals x minus 2. Let's look at another example. Here we have inputs of 1, 2, 3, 4 again, and our outputs are 2, 4, 6, and 8. So first you might ask yourself, how do I get from 1 to 2? Well, I could multiply by 2. I could add 1. Those are two different ways to get from 1 to 2. Let's see what works from 2 to 4. 2 times 2 is 4, but 2 plus 1 is not 4. So now we want to double check that this pattern of multiplying by 2 continues, and you can see that if we multiply by 2 our input, we do get the correct output. So when we write our function rule, we say y equals, and you can write x times 2, but typically we write that by saying 2x. So you're going to take your input, multiply it by 2 to get your output. Couple of definitions are independent variable and dependent variable. So the independent is the input of the function. These are the x values, also called the domain. And all of these terms are interchangeable. Then we have the dependent variable, or the output of the function. Those are the y values, or the range. And what's important to remember here is that the value of the dependent variable will depend on the value of the input. So your dependent variable changes depending upon your independent variable. And the language there may seem kind of confusing or wordy, but when you say it out loud, sometimes I think it makes a lot of sense. The dependent depends on the independent. So first we're just going to look at some examples where we're identifying the independent and the dependent variables. That will help you know what is x and what is y when you write function rules.
I want to read off the names for students of the month for...
Okay, sorry about that. So again, we're going to be identifying the independent and dependent variables. So in the winter, more electricity is used when the temperature goes down, and less is used when the temperature rises. So the first thing to understand is what are the two variables we're talking about. So when we look at that statement, we're talking about electricity and we're talking about temperature. So the question is, which one's the independent and which one's the dependent? So it says more electricity is used when the temperature goes down and less is used when the temperature goes up or rises. So the electricity is dependent upon the temperature. The amount of electricity that is used depends on the temperature. So the electricity is the dependent variable and the temperature is the independent variable. And something to recognize with temperature is that we don't have any control over that. And so that also can help you determine what's independent or dependent. Example 4, we have that the faster Ron walks, the quicker he gets home. So the faster Ron walks, the quicker he gets home. We're talking about Ron's speed versus the time it takes him to get home. So if the faster he walks, the quicker he gets home, the time it takes him is dependent upon his speed. So the time depends upon the speed. And if you try to say it the other way, it just really doesn't make a lot of sense. The speed he walks depends upon the time it takes him to get home. I mean, that just sounds really backwards when you say it out loud. So the time it takes him to get home depends upon the speed that he walks. So then we want to also talk about a function rule. And the function rule is just an algebraic expression that defines a function. And where students kind of get hung up here is that we start using this term f of x is how it's read, f of x. And I've used a lot of highlighting here to help kind of clean up how we write out these functions. So we say that the dependent variable is a function of the independent variable. Well, remember that the dependent variable is the y and the independent variable is the x. You can see I've replaced the words the dependent variable and the independent variable with y and x. The word is often indicated by an equals sign. And a function, we're going to start using this term f of x. So when we say y equals f of x, we're saying that these two pieces are interchangeable. So you can either write y or you can write f of x, and they indicate the same thing. So if I say y equals 5x or f of x equals 5x, we're saying the exact same thing. And clearly the student doesn't realize that I'm busy right now, so I apologize for that. So let's look at some examples where we are defining the independent and dependent variables, and then we're also writing a rule in function notation. So we have a lawyer's fee. It's $200 per hour for her services. So first we want to know the independent and the dependent variable. So does the fee depend upon the amount of hours she spends working, or does the amount of hours she spends working depend upon her fee? And hopefully you're recognizing that the fee depends upon the number of hours. So the fee is the dependent variable and the hours she works are the independent variable. So this is your y and this is your x. So we're going to write it in function notation. So instead of saying y equals, we say f of x equals. How would we determine the fee? Well, you're going to take $200 and you're going to multiply it times the number of hours she works, which is indicated by the letter or the variable x. So here's our rule in function notation. F of x equals 200x. So we input our independent variable, the x. Say she works 6 hours. We multiply 6 times 200, and we'll get the dependent variable, which is the fee of $1,200. Here's another example. We have the admission fee to a local haunted house is $8, and each additional haunted house in the area is $1.50. So what we want to understand here is what's dependent and what's independent. So the fee, $8, plus the additional amount of houses that you attend or go to are $1.50. So your cost or your fee, we'll call it cost/fee, is going to depend upon how many haunted houses. So how many additional haunted houses is going to be the independent variable. So the number of houses or the fee depends upon the number of houses you visit. So we would write f of x, and then the question is, how do we determine how much money is spent? Well, it says that the admission fee is $8, so we know we have to pay $8 for the first one, plus each additional haunted house in the area is $1.50. So here's where you kind of have to be careful. You can write this a couple of different ways. If you visit 7 haunted houses altogether, you have to remember that the first house was $8, so it's 6 more at $1.50. So you could do $1.50 times x minus 6. If x represents the number of haunted houses total. So if x represents the number of houses total, we have to subtract, sorry, I meant x minus 1 here. We have to subtract the first house out of the equation because the first house is $8. So you're taking $8 for the first house plus $1.50 for every additional house. And that's where that x minus 1 comes into play. And again, it's in function notation because we have f of x instead of y. And now we're going to look at just evaluating some functions. So we're going to plug in a given input and solve. Here I want you to just evaluate a function given this function rule. So the rule is, if I have a function in terms of x, I'm going to multiply it by a -5, and then I'm going to add 4. And so I want you to find the function value or the output when the input is -2. This says find f of -2. So to find f of -2, I'm going to plug a -2 in for x and then solve the expression. So -5 times -2 is 10. We're going to add 4 to get 14. So the function value at -2, our input is -2, our output would be 14. If we were to write that as an ordered pair, we would get -2, 14. Again, this is your independent variable, your x, your input, lots of different words here to describe that. Then you get your dependent variable. So the 14 was dependent upon what we plugged in, which was the -2. That's your y or your output. And don't get hung up so much on the notation. Just kind of take it for what it is. You're just plugging in this value for x. So let's look at another one. If f of x equals x squared minus 3, then you're supposed to find f of 1. So f of 1 would be 1 squared minus 3. So I'm taking the input of 1 and plugging it in for x. 1 squared is 1, and 1 minus 3 is -2. So if an input is 1, the output, given this function, is -2. Another example, now you're asked to find f of -3. And to find f of -3, we take -2. We're going to multiply it times -3 squared, and then add 3. So -3 squared, that's positive 9. So now we have -2 times 9 plus 3. -2 times 9 is -18. Now we're going to add 3 and get -15. So when the input is -3, the output is -15, according to this rule or this function. Let's look at absolute value. It's probably been a while since you've worked with absolute value, but now our input is -4. So when we input a -4, that says take 3 times -4 minus 5, and then take the absolute value. Remember, you take the absolute value at the very end, because an absolute value in this case kind of acts like parentheses. So you work inside out. So we take the absolute value of 3 times -4 is -12, and then we need to subtract 5. So we're taking the absolute value of -17, and the absolute value of -17 is positive 17. Remember, absolute value is a distance from 0. -17 is 17 units away from 0. So with an input of -4, we get an output of 17. In class, we will work on some practice worksheets to help further cement this idea of function notations and writing rules.